Okay, so I'm going to speak about low wind effect, but from the point of view of fluid dynamics that will serve as an input to SCAO simulations. So at ESO, a very important effort has been done to make a model of a CFD model of the E-ELT by Martin and Ron. And actually, so this model of the low wind effect is based on two steps. The first step is the CFD model itself, which permits to predict 3D distribution of the temperature in the E-ELT. And then the second step is the ray tracing through this temperature distribution, which permits to give the optical pulse difference map in the pupil. So one of the most important physical effects happening is the subcooling, which is the cooling down by metallic structures through radiation against the cold sky. You can see Ron's paper if you want information about that. So we have studied two scenarios, which are actually just represented by the difference of temperature we have between the metallic structures and the air. So there is one realistic one, which is -2K, and one more pessimistic one of -5 degrees. So a very important part of the model is the model of the telescope and telescope structure and dome. And this is very important to simulate very precisely the airflow. And so all these structures are embedded in a big air domain where we can vary the wind speed and wind direction. So here is a representation that shows what are the main contributors to this effect. So the effect is really a combination between the subcooling and the airflow. You can see, for instance, here, this is a M2 structure, which is a very big system, so very cold in terms of energy accumulated. And the wind flow just creates a wake of cold air. And we can see that in the 3D model, we can see that actually the M2 tower is also a very big contributor to this issue. And of course, we know already that the spider arms are also playing a very important role. So here I have just taken one example when the wind comes from the back. So here is the OPD map, and we have plotted here just two slices through the pupil in the direction of the airflow. And so one cut is through the spider arms, and the other cut is through the M2 obscuration. And actually, so what we see is very conform to what we expect from the physics. For instance, here a very big variation of OPD due to the cold wake created after the M2 obscuration. And there is something a bit less expected, which was what's going on near the spider arms, because the spider arms, they accumulate less energy if we want for this effect, but still they are very cold, and very near the spider arms we have this very steep wavefront, which can be of some effect for our problem. And we can see also that if we take one piece of wavefront as a reference, so we can clearly see that there is differential piston also happening. And so the peak to valley typical values that you get are up to 10 microns in this wavefront maps. So I used these wavefront maps to feed SCAO simulations. So I simulated the PDS case. So PDS is the commissioning tool for the E-ELT, and it includes a SCAO system in K-band. And actually in K-band, we are able to measure the differential piston between the segments. And this is what we see here. So that when we use 4,000 correction modes, actually the loop is stable, and we have a curve which is a Strel curve, which shows 85% of Strel, and which is very similar to the case without a low wind effect. So, but this is a very optimistic case because this is almost all the modes, all the correction modes. For PDS, we look more for a more reasonable case where we correct only 3,000 modes, and this actually failed. So here you can see the curve in orange is the curve, the instantaneous Strel curve when we have a front wind. So we have this low wind effect due to the front wind. And so for now, we cannot really conclude why it fails. I have some idea of why it fails, but I think it's interesting to see what the low wind effect can trigger as an issue in an AO loop. So here at right, there is a representation of one residual screen at one given time. So at iteration 0.8, which is here somewhere. And so in fact, we can clearly see here what are the big errors we face, because, well, we can see the uncorrected high spatial frequency, and then the low spatial frequency seems to be corrected, except for a piston between the petals. And we can see, of course, this very, very steep wavefront near the spiders that the AO DM cannot correct. So the M4, of course, has not enough resolution to correct that. So we will have this kind of problem in our systems. So as a conclusion, so we have a very detailed model now of the low wind effect. Of course, this needs to be confirmed. We made some simulations, but this needs to be confirmed, especially for the very steep wavefront near the spiders. We need higher resolution for that. So SCAO simulations have been made. We need to improve on the reconstruction part. And something I had promised for this work, but I didn't have the time to do, and is very important, is the M4 saturation problem, because with these very large P2 arrays, we may have also problems of M4. So for what concerns the CFD simulations, we need to improve them. We want also to look in what's going on if we open the louvers, because this may increase the airflow and hence decrease the low wind effect problem. And what we really want to do is to develop a parametric model of the low wind effect, such that we can then explore temporal variations without the need to run a very costly simulations. And we hope that this work can be an input for studying passive or active countermeasures if needed. Thank you.
Okay, thank you, Christophe. So you have a couple of questions here quickly. The first one, I think it's from Andrea Soberé. They're asking if you did the simulation in Octopus. Probably a quick answer here.
Yes.
Yes. Okay. And then the other one, that's an interesting one, actually. Let's say, would it be possible to get access to the simulated OPD into the dome or the E-ELT?
So the OPD maps, but I have nothing else to share them. I just think we need to precise what is the framework of that, because I don't think that there is not yet an ISO stamp on it. It's really individual initiative for the moment. So
yeah, it's an interesting point, Christophe. I think those data will be very useful, but of course ISO has to first of all, assess them, and then. But I think they would be very valuable. So okay, I think you have maybe another couple of questions on Slack, Christophe. You may reply there.
Okay. No problem.
Thanks again, and we move.
Thanks a lot. Bye.